Hello, this is Modumath Tape 2.3. The subject is adding fractions with the same denominator. We'll also have something to say about improper fractions and mixed numbers. Modumath Text 2.3 goes with this tape. Open to the text now. Also, keep pencil and paper handy to work problems and take notes. To get some feeling for adding fractions, let's remind ourselves of what it means to add whole numbers. Suppose we want to add 3 and 1. We start at 0 on the number line, move 3 units to the right, and then move 1 more. Where do we end up? At 4. 3 plus 1 equals 4. Suppose now that instead of adding 3 and 1, we add 3/5 and 1/5. We start at 0 on the number line, move 3/5 of a unit to the right, and then move 1/5 more. Where are we? At 4/5. So we say 3/5 plus 1/5 equals 4/5. To add 2/7 and 3/7, we start at 0, move 2/7 of a unit to the right, and then continue another 3/7. We find ourselves at 5/7. 2/7 plus 3/7 equals 5/7. This suggests a very simple rule for adding 2 or more fractions with the same denominator. The sum itself will be a fraction with a numerator and a denominator. The denominator poses no problem. It will be the same as the original one. As for the numerator, we obtain it by simply adding together all the original numerators. Here are a few examples. In mathematical language, we say if A over C and B over C are any fractions, where C stands for the same number in both places, then their sum is A plus B all over C. Here are some problems to try yourself. They appear in your Modumath text as Exercise 1. Compare your answers with those shown. Notice that in the last case, we reduced the answer to lowest terms. This isn't essential, but sometimes it's a good idea. Adding fractions with the same denominator isn't hard, but there's one trouble spot. Look at these two problems. 4/7 plus 5/7 equals 9/7. 5/8 plus 3/8 equals 8/8. In each case, the numerator of the sum is equal to or even larger than the denominator. Fractions like these are known as improper fractions. By contrast, a fraction whose numerator is less than its denominator is called a proper fraction. The names are unfortunate because to mathematicians, improper fractions are just as good as proper ones. But for ordinary purposes, people tend to shy away from them. For example, there's nothing wrong mathematically with saying we bought 3/2 of a pound of apples, but it's certainly more natural to say we bought 1½ pounds. The second form, 1 1/2, is known as a mixed number because it combines a whole number with a fraction. It's the same amount of apples, 3 halves certainly equals 1 1/2, but 1 1/2 just sounds better. This means that when we're working with fractions and the result is an improper fraction, we should be able to change it to a mixed number. Other times we'll want to change mixed numbers to improper fractions. In this tape, we'll learn to do both. We'll begin by changing mixed numbers to improper fractions. What do we mean by the mixed number 1 1/2? If we think of it as money, it's $1 plus half a dollar. If we think of it as distance, it might be a mile plus a half mile. If it's a point on the number line, we can get there by adding 1 1/2. In every case, we seem to be adding, and in fact, the mixed number 1 1/2 is just a short way of writing the sum 1 plus 1/2. Similarly, 3 1/2 equals 3 plus 1/2. 5 1/4 equals 5 plus 1/4, and so on. A mixed number is the sum of a whole number and a proper fraction. This is the important idea behind changing a mixed number to an improper fraction, which is something we have to do whenever we want to multiply or divide fractions, or even to add or subtract them. Let's change the mixed number 3 1/2 to an improper fraction. Think of 3 1/2 as 3 plus 1/2. We know that 3 can be written 3 over 1, or multiply numerator and denominator by 2, 6 over 2. So instead of writing 3 plus 1/2, we can write 6 halves plus 1/2, which, as we just saw, equals 7 over 2, or 7 halves. So the mixed number 3 1/2 is equal to the improper fraction 7 halves. Let's try another one. Change 8 2/3 to an improper fraction. This time, part of the work is left to you. Fill in the blanks as you come to them. Look over the work carefully. Read it to yourself, step by step. If you had any trouble, turn off the tape and ask someone to help you. Now that you have the general idea, it's time for a shortcut. We want to change, say, 8 2/3 to an improper fraction. This fraction will have a numerator and a denominator. The denominator is easy. It's the original denominator, 3. As for the numerator, we can get it in 2 short steps. First, multiply the denominator, 3, and the whole number 8. This gives us 24. Then add the old numerator, 2. These 2 steps give us 24 plus 2, or 26 thirds, which is the same result as we obtained earlier. There's a pattern here. Start by multiplying these 2 numbers and then add the numerator. Similarly, if we want to change 2 6/7 to an improper fraction, the new denominator is 7, while the new numerator is 7 times 2, or 14, plus 6, which is 20. Try the next problem yourself. Remember, to get the numerator, first multiply, then add. Compare your answer with the one shown. There are more practice problems in your Modumath text. They're not hard once you get used to them. Now that we can change mixed numbers to improper fractions, let's look at the reverse, changing improper fractions to mixed numbers. Let's change 13/4 to a mixed number. A fourth is a quarter, so imagine we actually have 13 quarters American money. We begin by arranging these quarters into groups of 4 each. Each group is equal to 4 quarters, or $1. We can construct $1, $2, $3 with one of the quarters left over. So 13 quarters equals 3 1/4. Similarly, take the fraction 17/6. Think of each of those sixths as a slice of pizza, the kind where there's 6 slices to a pie. Then changing 17/6 into a mixed number is like asking how many entire pizzas did we start with and how many extra slices. We work backwards. We rearrange those 17 slices into 2 full circles of 6 slices each, and we have 5 of the slices left over. This tells us that 17/6 equals 2 plus 5/6, or 2 5/6. Again, there's a shortcut. To change 17/6 to a mixed number, we don't have to sit counting slices of pizza. We can get exactly the same information if we just divide 17 by 6. The quotient, 2, is the whole number part of the mixed number we're after. The remainder, 5, is the numerator of the fraction. Work one yourself for practice. Express 34/10 as a mixed number. All we do is divide 34 by 10. The quotient is 3, and the remainder, 4. So 34/10 equals 3 4/10. Or, if you want to reduce the fractional part, 3 2/5. If you had any difficulty with this, replay the last few minutes of the tape or ask someone to help you. Otherwise, you're ready to return to the problem that started it all. 4/7 plus 5/7. Only it's not a problem anymore. 4/7 plus 5/7 equals the improper fraction 9/7. For some purposes, this result is perfectly acceptable, especially if we plan to use it in further computations. But for other purposes, we want to change it to a mixed number. So we divide 9 by 7, obtaining a quotient of 1 and a remainder of 2. Conclusion: 9/7 equals 1 2/7. Or, putting it all together, 4/7 plus 5/7 equals 9/7, which is 1 2/7. The method also works for more than 2 addends, as shown. Here we're adding 7/8, 3/8, 7/8, and 5/8. We'll do it in 2 steps, adding and changing. When we add, the sum is an improper fraction. 7 plus 3 plus 7 plus 5 all over 8, or 22/8. Changing this to a mixed number, we get 2 6/8, or 2 3/4. Of course, if you can do the division in your head, you don't need to write it out. Take a minute to do this problem yourself. Show your answer in the form of a mixed number. How does your answer compare with the one shown? Again, we did it in 2 steps, adding and changing. But solving one problem just creates another. To handle improper fractions, we introduced mixed numbers. Now the question arises, how do we add mixed numbers? Nothing to it. Just add whole numbers and fractions separately and combine the results. For example, suppose we want to add 3 1/5 and 4 2/5. So the problem becomes 3 plus 4 plus 1/5 plus 2/5. 3 plus 4 is 7. 1/5 plus 2/5 is 3/5. Combining the results, we get 7 plus 3/5, or 7 3/5. If you're adding a combination of whole numbers, mixed numbers, and fractions, the idea is the same. Group all the whole numbers and all the fractions separately. Add each group and combine the results. Here, this example is worked out for you. Go over it carefully. There's one altogether different way to add mixed numbers. It's easier in theory, but harder in practice. It's simply this. To begin, convert all mixed numbers to improper fractions. Then add as usual. Your answer will be an improper fraction. To complete the problem, change the answer back to a mixed number. Let's try the very first example by this method. The problem was 3 1/5 plus 4 2/5. Convert to improper fractions as shown. Adding, we get 38/5, which, changing it back to a mixed number, is 7 3/5. Of course, the answer is the same as our earlier one. The first method, working with whole numbers and fractions separately, is useful chiefly in addition. If you want a short way to add, and don't mind learning a different method for everything else, then it's fine. But if you'd rather learn a single approach that works with all the operations of arithmetic, adding, subtracting, multiplying, and dividing, stick with the second method, changing the mixed numbers to improper fractions and then using the rules for fractions. Let's review the main ideas of this tape. First, we learned to add fractions with the same denominator. This was easy enough, but it led us to improper fractions, which caused complications. To deal with the improper fractions, we introduced mixed numbers. We then learned to change mixed numbers to improper fractions, and vice versa. But introducing mixed numbers raised a new difficulty. How do we add them? So we concluded with 2 different ways to solve this problem. If you had any difficulty with the ideas of this lesson, replay the tape or ask someone to help you. Otherwise, you're ready for the problem session in your Modumath text.